Welcome to this video where we're going to be talking about the solution guided meshing inside of the GIS mesher. The GIS mesher is a application that we can use to create meshes leveraging your favorite GIS application. So it takes inputs of text files and GIS files and creates a mesh, spits it out in SMS format that's used by TUFLOW-FV, SRH2D, and other hydraulic models. It creates hybrid quadrilateral and triangular meshes. It can support the use of break lines. You can define size information at points or polygons, and elevation data from raster data or polygons. And it can also set up node strings. So it can set up a complete mesh for use with TUFLOW-FV or similar models. If you're not familiar with the GIS mesher, it's probably beneficial for you to go back and watch some of the other videos before learning about solution guided meshing. So you can go to the website www.risingwatersoftware.com and find the other videos. Solution guided meshing takes mesh size and orientation information based on an initial solution. You're going to create a quick and dirty mesh that you'll be able to use to set up meshes or set up the meshing parameters. Excuse me. And typically we're going to base the sizes on the depths and velocities, and you can have areas of additional refinement as needed. So on the right, we're seeing the test case that we're going to be looking at today. This is the quick and dirty mesh that I referred to. That initial mesh looks, the setup for it kind of looks like this on the right. We have most of the area is covered by 6-meter constant cells, with a small area where we've refined it down to 2-meter cell sizes. To be able to use the solution guided meshing, the steps are we create an initial mesh with break lines like we've got there. Often, like I say, it's a quick and dirty mesh, something that we can set up really quickly using the standard tools. We're going to run the model with that mesh, and then we're going to use the GIS mesher in what we call generate mesh inputs mode, which is the solution guided meshing mode, where we're going to use the solution to create some inputs to be able to create a new mesh from. So it's a little bit of an iterative process. We have a few options that we can use. We can have different time steps. In our case, we're going to hold a low flow for a period of time. We're going to sample the values at the end of that, and then we're going to transition to a high flow period and then use the values for that. So we'll be able to differentiate between areas that are wet and low flow, more of the channel areas, and areas that are wet only during the high flow situations. Average and maximum values can also be used, especially maximum values will be useful in like a coastal situation where you don't really have specific time steps. You've got a tidal condition, so a low flow, high flow may not make as much sense. The other thing that we're going to show here is we're going to be able to use SQL commands to be able to assign the cell sizes based on this solution information. So with that, we're going to move on to our demo portion. Just a little bit. This is that same example that we've been looking at. You know, using the setup, we create these mesh elements. So you can see that this is showing the contours of the bathymetry. You can see that the channel's captured okay, but not great. It's got some places where it's kind of misses. The cells are all just pretty uniform, which is okay, but we could improve our run times by having coarser cells in some areas, but we're not really picking up the channel, which is the big problem, is it's not as continuous as we'd like it to be. And ideally our cells would be oriented to the direction of flow. So we can make some improvements on this mesh, and we could do it by hand, but that would take quite a bit of work and effort. And so we're going to be able to use the solution guided meshing to create a next version of a new version of the mesh really pretty quickly and slickly. Slickly is not probably a technical, it's a technical term. Um, we're gonna. This is the solution. I'm just looking at it here in QGIS. We're gonna look at using. We're gonna use the TUFLOW viewer here to look at things. So this we're looking at time step at 3 hours. So this is kind of the end of the low flow periods. We can see mostly the flows are in the channel. A little bit out here. Over here we've got kind of an inflow that kind of pools in this area. And then if we look at 6 hours, this is kind of the high flow situation. For the high flows, so that we would have information beyond any of the solutions that we were going to be looking at. I put in a flow for this high flow situation that's higher than what we plan to simulate in our model. So that's a little bit about what the initial model and solution and mesh look like. So we'll move on to setting up the solution guided meshing. So what we're going to do is over in our meshing, I've set up this area for our solution guided meshing, and it's got this meshing folder in here. And this is the control file that we used to set up the mesh the first time. And rather than have you watch me type, I'm going to go ahead and bring over one that we're going to use to generate our mesh inputs. So this only has a few commands here. This is just a simple text editor. We're going to use this operation generate mesh inputs. That kicks it into this solution guided meshing mode. And we're going to give it a working projection. So this was just information that, projection file that I had created from QGIS, copied it over. We're going to take the mesh points from NetCDF. So this, when we run the FV model, we need to tell it to run or to output NetCDF options at the cell centers. So that's the information that we're going to be using in our model. And we're going to extract the data from times 3 and 6. And we're also going to read in this mesh points information, which is that's that refined point, or that's the original size function. We're going to be using that information as well. And we're going to tell it to write this mesh points from solution file. So go ahead and go back to the GUI. I'm going to tell it to run this file here, tell it to run. It spits out in a second that it created this file. So if we go over to this GIS file and look at it inside of QGIS, mesh points from solution, these are all the points that it had. And if we look at the table, the attribute table, it's going to have some information. It's going to have these first few columns. This is the information that's required for the meshing command that we're going to use. It has a direction primary, a size primary, and a size secondary. The direction primary has been populated with to orient with the velocities that were read in from the solution. So it's set up to favor the first one that we read in. So we did the low flow scenario. If it was wet in that scenario, then it's going to be oriented in that direction. If it wasn't, but was wet in the high flow scenario, which all of the points that are kept were, it orients them based on that high flow. So if we have little wiggles that are in the low flow but not in the high flow, they're going to get captured as the wiggles in our mesh. So our mesh will be able to be valid for low and high flow. If you only want to mesh for high flow situations, you might want to just run a high flow scenario and have it not try to follow the little wiggles and bends. You'll notice our size primary and our size secondary are at 0. That's because we haven't given it any information on how to set those. Depth 1 is the depth at the low flow, and depth 2 is the depth at the high flow scenario. Same with velocity mag, low flow, high flow. Velocity direction, low flow, high flow. Then we have some of these that start BGM. That's for background mesh. So this is our primary size and our secondary size for our background mesh. So this was the mesh, this was the size information that was used previously. And so we've got all of this information that we're going to take and be able to create a mesh, but we haven't filled in the size primary and size secondary. But we have all of these other columns that we can use to try to set those size primary and size secondary. Now we could come in and use the field calculator to kind of set those, look at each of the, think about how we want to use the depths and the velocities and the original size information to set those primary and secondary sizes. But instead we're going to come in and we're going to set some commands, some SQL commands inside of our meshing control file that we're going to use instead. Again, so that you don't have to sit and watch me type, I've got those stored away. Oops, so they're right here. I'll copy them over and then I'll explain them really quickly. So this begin generate SQL. This is saying we're going to start some SQL commands. Each command is going to end with a semicolon. So there's a series of commands here. This first command is to set the size primary based on cases. So we're going to say if the depth 1, so if the low flow depth is greater than 0.1 meters, then we're going to do an embedded case if it's greater than 0.1 and the velocity mag is greater than 0.2 meters per second. Then we're going to set the size primary, so in the direction of flow, to 3. And then otherwise, if it's deeper than 0.1, but the velocity mag is too low, it's kind of a ponded area or something, then we're going to set it to 4. Otherwise, we're going to set it to 5. So if we weren't wet in the low flow case, only in the high flow, we're going to assume it's outside of the channels. It can be a little bit bigger, and so we're going to have a 5 meter cell size. Then the second command says make the cell size primary be equal to the background mesh size primary wherever it's smaller than the size we compute. So we compute a size and then say, well, if the background mesh is smaller, so in our case we have this area that's really refined in here, if that's smaller, go ahead and use that instead. Then we do kind of a similar thing with the secondary size. If the low flow depth is greater than 0.1, and the velocity at low flow is greater than 0.2 meters per second, make it 1.5. So we're going to make it thinner in the areas that are that we're assuming are channels based on the fact that they have a depth and a higher velocity. Otherwise, it's going to set up to be. Otherwise, it's going to be a little bit coarser with a 4 meters in the direction opposite of flow. It's perpendicular to flow. And then if it's an area that wasn't wet at low flow, then we know it's wet at high flows if we have a high velocity mag over 0.2 meters per second. Then we're going to make it a little bit narrower again because it's got a pretty good flow direction, and so we're going to make it a 3 meter cell, otherwise make it 5. And again, this final thing is just saying, well, if our background mesh size was smaller, go ahead and use that. And then we end the generation of SQL. So I'm going to unload this layer and go back to my GIS mesher and rerun that command. And now we see those commands come through. It takes half a second longer, and we can go, oh, sorry, wrong one, wrong thing. So now we come back, we can look at this mesh points from solution, and now we have information for the size primary and size secondary. So now we can come back to our meshing. We can create a new meshing control file that's based on our first one. and I'm just going to call it tutorial 2. And I'm going to just double check something really quick. All right, so so I just wanted to double check something. What we do is we come in and we're going to say read the mesh points with direction, and we're going to use, instead of using that other one that we used, we're coming in here and we're saying use mesh points from solution 002. And so with adding this with direction changes the fields that it expects. It expects those direction information in addition to the size information. And so that's the only change we need to use to make our new mesh. I'm going to turn this off, go back to our mesher, tell it to use this new meshing control file, tell it to run. And now it's going to take a little bit longer to generate the mesh than it did the first time when I generated the initial mesh, because now it's got all of these points that are giving it a constraint. All those points are telling it, well, here I want you to orient this direction and have this size. So it's got to try to resolve and meet all of those different points in there. But the fact that it's doing that makes it so we can create a pretty nice mesh really pretty fast. And this is a pretty simple example. We could probably click this out and make a good mesh, not too bad. But the more complicated the domain, the more you're going to save by using this solution guided meshing. So now let's go ahead and look at what we came up with. So we go back to our meshing folder, look at the output, and we look at our tutorial 2 shapefile. And so we can see, I'm going to go ahead and turn on view, panels, layer styling. So I'm going to say do graduated. I'm going to give it the Veritas, and I'm going to base it on the Z. And I'll do equal interval of 55 classes. All right, so we can see, we zoom in here, our cells are elongated pretty well with the channel. We're going in the direction of flow. You know, we don't maybe pick up every little part of the channel. We might need to go a little bit thinner still, or use this as a starting mesh to do it again to get some of them a little better. But overall, we've got a pretty nice mesh in here. It goes coarser as we get away from the area of interest, follows the flow paths, orients along those cells. We've maintained this area where we've forced it to be finer in there. So we could go ahead and take this and run FV again. So, you know, a few short steps, we were able to create a very detailed mesh, follows all of these different channels and flow paths. And we didn't have to click them out or set specific sizes. We can still use all of the options like multipliers and things to be able to tweak that mesh setup and be able to make it coarse. We can do some things to make it coarser outside of the flow areas. But yeah, a lot of different options that we can do from there. But that's a quick overview of solution guided meshing inside of the GIS mesher. If you have any questions, you want to learn more, go to the website, www.risingwatersoftware.com. Thank you.